There are people walking among us right now who would rather spend their entire lives alone than risk the vulnerability of love. Not because they don't want connection, not because they're incapable of feeling, but because somewhere deep in their neural circuitry, their brain has calculated that isolation is safer than intimacy. And what if I told you that this isn't just a preference or a personality trait? It's a survival mechanism backed by hard neuroscience, and the research reveals something profoundly dark about how the human mind protects itself by choosing loneliness over the possibility of being hurt again. Let me start with a study that should immediately shift your perspective. In 2017, researchers at the Max Planck Institute published findings in the journal Nature Neuroscience that examined what they called social pain processing in individuals with histories of rejection or abandonment. They used fMRI imaging while showing participants images associated with past romantic rejections. What they found was extraordinary. The brain regions that activated were the same regions that process physical pain, the anterior cingulate cortex and the insula. But here's what's crucial. In people who had chosen solitude over relationships, these regions showed hyperactivation that persisted long after the image disappeared. Their brain wasn't just remembering pain, it was re-experiencing it at full intensity, sometimes hours after the initial trigger. Social rejection had created what neuroscientists call a pain memory that was so powerful, so vivid, that their brain had learned to avoid anything that might trigger it again. And the most effective way to avoid social pain is to avoid social connection entirely. Solitude becomes not a choice, but a defense mechanism, a neural fortress built from the rubble of past wounds. Before we go deeper, you need to understand what happens in the brain when we form attachments. When you fall in love or form a deep connection, your brain releases a cascade of neurochemicals: oxytocin, dopamine, serotonin, endorphins. These chemicals literally rewire your neural pathways, creating what neuroscientists call reward prediction errors. Your brain learns to associate that person with pleasure, safety, and reward. The ventral tegmental area, your brain's reward center, lights up when you see them, think about them, or anticipate being with them. But here's the devastating part. When that attachment is severed, through betrayal, abandonment, or loss, your brain doesn't just lose the reward. It experiences what researchers call reward withdrawal, which is neurologically similar to drug withdrawal. A 2015 study published in the Journal of Neurophysiology found that individuals going through heartbreak showed brain activity patterns nearly identical to cocaine addicts in withdrawal. The nucleus accumbens, which had been flooded with dopamine during the relationship, suddenly crashes, creating intense psychological pain. Now, imagine this happens not once, but repeatedly. Each time you open yourself to love, each time you allow attachment, each time the bond breaks, your brain is taking notes. It's building a predictive model. And eventually, that model reaches a conclusion. Attachment equals pain, therefore avoid attachment. This isn't conscious reasoning. This is deep learning happening at the level of neural networks, below the threshold of conscious awareness. A groundbreaking 2019 study from University College London, published in Social Cognitive and Affective Neuroscience, examined what they called attachment avoidance neural signatures. They recruited participants with avoidant attachment styles, people who preferred solitude and felt uncomfortable with closeness, and compared their brain activity to securely attached individuals. The results revealed something profound about how the brain adapts to protect itself. When shown images of intimate situations like couples embracing, holding hands, or showing affection, the avoidantly attached individuals showed increased activation in the prefrontal cortex, particularly the dorsolateral and ventrolateral regions. These are areas involved in cognitive control and emotion suppression. Simultaneously, they showed decreased activation in regions associated with reward and pleasure. Their brain was actively suppressing the natural reward response to connection and intimacy. They'd trained their neural circuitry to find connection threatening rather than rewarding. But why? What creates this neural rewiring? The answer takes us into attachment research and some of the most important psychological science of the last century. Research published in Developmental Psychology in 2020 followed children from infancy through adulthood, tracking their attachment patterns and their later relationship preferences. What they found was that children who experienced inconsistent caregiving, where sometimes their needs were met and sometimes ignored or punished, developed what's called disorganized attachment. Here's what happens neurologically in these children. Their brain is trying to solve an impossible problem. The person who is supposed to be their source of safety is also their source of threat. This creates what researchers call fear without solution. The amygdala is signaling danger, but there's nowhere to run because the danger is the attachment figure. Over time, this teaches the developing brain that attachment itself is dangerous. The very thing they need for survival becomes associated with threat. A 2018 study, published in Attachment and Human Development, used neuroimaging to examine adults with disorganized attachment histories. They found persistent alterations in the circuitry connecting the amygdala to the prefrontal cortex. Specifically, there was reduced connectivity, meaning the prefrontal cortex had difficulty regulating the amygdala's fear responses. When these individuals encountered opportunities for intimacy, their fear system activated, but they lacked the neural infrastructure to calm that fear. The result? Avoidance felt like the only option. Now let's talk about the role of prediction in the brain, because this is fundamental to understanding why solitude can feel safer than love. Your brain is fundamentally a prediction machine. Research from the Wellcome Center for Human Neuroimaging, published in 2021 in Nature Reviews Neuroscience, explains that the brain constantly generates predictions about what will happen next and compares those predictions to reality. When reality matches prediction, you feel safe. When reality violates prediction, you feel anxiety. For people who have been hurt repeatedly in relationships, their brain's predictive model says, if you get close to someone, they will hurt you. Solitude, while lonely, is predictable. You know exactly what to expect. There are no surprises, no betrayals, no abandonments. Love, on the other hand, is fundamentally unpredictable. You're placing your emotional well-being in someone else's hands, and your brain has learned that this is dangerous. The anxiety of unpredictability feels worse than the pain of loneliness, because at least loneliness is certain. A fascinating 2020 study published in Emotion examined what researchers called intimacy anxiety, using real-time physiological monitoring. They had participants engage in conversations designed to gradually increase in intimacy, from small talk to personal disclosure. As the conversations became more intimate, individuals who preferred solitude showed increasing physiological stress markers, elevated heart rate, increased skin conductance, rising cortisol. Their body was treating intimacy like a threat, activating the sympathetic nervous system's fight-or-flight response. But here's what's particularly revealing. When these same individuals returned to solitude after the interaction, their physiological markers didn't just return to baseline. They dropped below baseline, showing what researchers called relief response. Solitude wasn't just neutral for them. It was actively rewarding, triggering a decrease in stress hormones and an increase in parasympathetic activity. Their nervous system had learned to experience aloneness as safety and connection as danger. Let's examine research on what's called self-sufficiency schemas, published in 2019 in the Journal of Personality. The researchers identified a subset of individuals who had developed elaborate psychological frameworks around not needing others. These weren't just beliefs. They were organized systems of thoughts, emotions, and behaviors designed to reinforce independence and devalue connection. Brain imaging showed that when these individuals thought about self-sufficient scenarios, they showed activation in reward centers. They'd literally rewired their brain to find independence pleasurable. The study included interviews that revealed the function of these schemas. Many participants described past experiences where depending on others led to disappointment, betrayal, or exploitation. The self-sufficiency schema emerged as a solution. If I don't need anyone, no one can hurt me by leaving or letting me down. It's a logical solution to an emotional problem. The only issue is that it requires denying a fundamental human need for connection, which creates its own form of suffering. Research on loneliness provides a crucial perspective here. A 2018 meta-analysis published in Perspectives on Psychological Science analyzed over 200 studies on loneliness and found something counterintuitive. Chronic loneliness is associated with increased mortality risk equivalent to smoking 15 cigarettes per day. It increases risk of cardiovascular disease, stroke, dementia, and depression. The human body is not designed for prolonged isolation. And yet, for people who find solitude safer than love, they're choosing this health risk because the alternative feels more dangerous. A 2021 study in social neuroscience examined what happens in the brain during prolonged social isolation. Using participants who spent 10 days in controlled isolation, researchers found increased activation in the substantia nigra and ventral tegmental area when participants viewed social images. These are regions associated with craving, similar to what occurs in addiction and hunger. The brain was generating a craving for social connection even as the person consciously preferred solitude. There was a war between biological need and psychological defense. Now, let's talk about the concept of vulnerability phobia, which is distinct from social anxiety. Research published in 2020 in the Journal of Anxiety Disorders identified individuals who don't fear social interaction per se. They can navigate social situations, hold conversations, even appear charming and engaging. What they fear specifically is vulnerability, the emotional exposure that comes with genuine intimacy. And the only way to avoid vulnerability is to keep everyone at arm's length. The researchers used a clever paradigm where participants engaged in interactions with varying levels of emotional disclosure. Some conversations involved factual information, others involved personal thoughts and feelings. Brain imaging revealed that for vulnerability-phobic individuals, only the emotionally intimate conversations triggered threat responses. The amygdala activated, the anterior cingulate cortex showed increased activity indicating conflict monitoring, and the insula processed visceral discomfort. Being truly seen felt dangerous. A 2019 study from Stanford University, published in Psychological Science, examined what they called intimacy catastrophizing. They asked participants to imagine various intimate scenarios, from sharing a secret to saying, "I love you," to depending on someone during crisis, and rate the likelihood and severity of negative outcomes. People who preferred solitude consistently overestimated the probability that intimacy would lead to rejection, betrayal, or abandonment, often by factors of 10 or more compared to actual base rates. The study revealed a cognitive distortion. The brain was using past experiences to predict future ones with inappropriate certainty. Just because someone was hurt before doesn't mean they'll be hurt again, but the brain treats past events as perfect predictors of future events. This is called overgeneralization, and it's a core feature of anxiety disorders. The person has essentially developed an anxiety disorder specifically about intimacy. Let's examine research on what happens in the brain during moments of connection versus moments of solitude. A 2020 study published in Nature Communications used experience sampling combined with fMRI to capture brain activity during naturally occurring social interactions and periods of solitude. They found that during genuine connection, even in people who preferred solitude, there was activation in the reward system, the medial prefrontal cortex, and the temporoparietal junction. The brain was responding positively despite the person's stated preference. But here's what's crucial. Immediately after the interaction ended, in solitude-preferring individuals, there was a surge of activity in the amygdala and the dorsolateral prefrontal cortex. It was as if their brain was retrospectively reprocessing the interaction as a threat. The researchers called this delayed threat appraisal. The person could enjoy connection in the moment, but afterward, their threat detection system would activate, scanning the interaction for danger, finding reasons why the connection was risky, generating anxiety that reinforced their preference for solitude. Research on self-protective mechanisms in relationships, published in 2021 in the Journal of Personality and Social Psychology, identified several strategies people use to maintain distance while appearing connected. One is called pseudo-intimacy, where the person shares information that seems personal but is actually carefully curated to maintain control and avoid true vulnerability. Another is preemptive withdrawal, where they pull away before the relationship can deepen. And another is intimacy cycling, where they alternate between closeness and distance, never allowing sustained vulnerability. The researchers found that these strategies are neurologically reinforced because they work in the short term. Each time the person avoids vulnerability and doesn't get hurt, their brain's prediction that intimacy equals danger gets confirmed. It's a self-fulfilling prophecy. They never test whether intimacy with a safe person might be different because they never allow themselves to be vulnerable enough to find out. A particularly illuminating study from 2019, published in Attachment and Human Development, examined what happens when solitude-preferring individuals actually form close relationships despite their fears. The researchers followed individuals through the early stages of romantic relationships, tracking their brain activity, stress hormones, and subjective experiences. What they found challenges the simple narrative that these individuals just need to open up. Even in objectively healthy relationships with partners who were consistently supportive and trustworthy, the solitude-preferring individuals showed persistent physiological stress responses to intimacy. Their cortisol remained elevated, their heart rate variability remained low, indicating an inflexible nervous system, and their brain continued to show threat-related activation during intimate moments. The issue wasn't just cognitive. Their entire nervous system had been conditioned to perceive intimacy as danger, and that conditioning didn't reverse quickly even in safe circumstances. Now let's talk about the role of control, because this is fundamental to understanding the appeal of solitude. Research published in 2020 in the journal Cognition examined the neural correlates of perceived control in social versus solitary situations. When people were alone, they showed increased activation in brain regions associated with autonomy and self-agency. When with others, especially in intimate contexts, these regions showed decreased activity. Being with others meant surrendering some control, and for people with histories of unpredictability or betrayal, loss of control feels existentially threatening. The study found that solitude-preferring individuals showed particularly strong activation in the dorsal anterior cingulate cortex when anticipating loss of control in social situations. This region is involved in monitoring for conflicts between desired states and actual states. Their brain was essentially running a constant background program asking, "Am I losing control? Am I becoming vulnerable? Am I in danger?" And the only way to quiet that program was to maintain distance. Research on trust provides another crucial angle. A 2018 study published in Nature Neuroscience examined the neurochemistry of trust using economic games where participants decided whether to trust others with resources. They found that trust involves oxytocin release in the brain, which promotes social bonding and reduces amygdala activation. But in individuals with trust impairments from past betrayals, this system was dysfunctional. They showed blunted oxytocin responses and persistent amygdala activation even with trustworthy partners. The researchers described it as broken trust circuitry. The neural machinery that allows humans to form trusting bonds had been damaged by repeated violations of trust. And without the ability to trust, genuine intimacy becomes nearly impossible. You can go through the motions of relationship, but there's always a part of you waiting for betrayal, always a part of you that remains guarded. That's exhausting. Solitude eliminates the need for trust entirely. Let's examine research on what's called emotional forecasting in the context of relationships. A 2021 study in the Journal of Experimental Psychology asked solitude-preferring individuals to predict how they would feel in various relationship scenarios, both positive and negative. The findings revealed a systematic bias. They underestimated the positive emotions they would experience from connection and overestimated the negative emotions they would experience from rejection or conflict. This forecasting error is crucial because it influences behavior. If you believe that relationships will bring minimal joy and maximum pain, why would you pursue them? The problem is that the forecast is based on a brain that's been shaped by past trauma, not on objective reality. It's like trying to predict tomorrow's weather by only remembering storms and forgetting sunny days. The prediction system itself is biased. A fascinating line of research examines what happens to the brain during prolonged voluntary solitude versus forced isolation. A 2020 study published in Biological Psychiatry compared individuals who chose solitude with those who were socially isolated due to circumstances beyond their control. Both groups showed neural signatures of loneliness, including heightened vigilance for social threats. But the voluntary solitude group showed something additional: increased activity in regions associated with rationalization and meaning-making. Their brain was working overtime to justify the choice, to construct narratives about why solitude was not just safer, but actually superior. They convinced themselves they were introverts, or independent, or didn't need people, when in reality their nervous system was still craving connection. It's a form of cognitive dissonance reduction. The brain can't tolerate the contradiction between biological need and behavioral choice, so it rewrites the story to eliminate the conflict. Research on intimacy repair is particularly important because it addresses whether this pattern can change. A A 2021 study published in Clinical Psychological Science tested an intervention specifically designed for individuals with intimacy avoidance. The treatment combined exposure therapy, where participants gradually engaged in increasingly intimate interactions, with neurobiological education about how their brain had been shaped by past experiences. The combination was crucial because understanding the neuroscience helped participants externalize the problem. Instead of "I'm broken" or "I'm incapable of love," the framework became, "My brain learned to protect me in a dangerous environment, but that protection is now a prison." This cognitive shift allowed participants to approach intimacy as a learning process rather than a test of their worth. Brain imaging before and after the 16-week treatment showed significant changes: decreased amygdala reactivity to intimate scenarios, increased connectivity between the prefrontal cortex and limbic system, and normalized activity in reward centers during connection. But the success rates revealed something sobering. Only 58% of participants showed significant improvement, and even among those, many reported persistent discomfort with vulnerability. The treatment helped, but it didn't erase decades of neural conditioning. The brain had built highways of avoidance, and creating new pathways for connection took sustained, uncomfortable effort that many couldn't maintain. A 2019 study in the Journal of Traumatic Stress examined the specific role of betrayal trauma in creating intimacy avoidance. Betrayal trauma occurs when the person who harms you is someone you're dependent on or deeply connected to. The researchers found that betrayal trauma specifically damages the neural circuitry involved in trust and safety detection. Using fMRI, they showed that betrayal trauma survivors had impaired functioning in the ventromedial prefrontal cortex, which is crucial for assessing trustworthiness and safety of others. This means that even when they encountered genuinely safe people, their brain couldn't accurately detect that safety. They were essentially flying blind in social situations, unable to distinguish safe from unsafe because their detection system was broken. For these individuals, solitude wasn't just emotionally safer. It was the only environment where they could accurately predict and control their level of safety. Let me share one final study that synthesizes much of this research. A 2022 longitudinal study published in Psychological Science followed 1,500 individuals over 20 years, tracking their relationship patterns, health outcomes, and brain structure. They identified a subgroup who consistently chose solitude over intimate relationships and found striking patterns. These individuals showed accelerated cortical thinning in regions associated with social cognition, particularly the superior temporal sulcus and the medial prefrontal cortex. The researchers proposed a devastating cycle. Avoiding intimacy meant less practice with social-emotional skills, which led to neural atrophy in regions supporting those skills, which made intimacy even more difficult and anxiety-provoking, which further reinforced avoidance. It's a use-it-or-lose-it phenomenon. The neural infrastructure for deep connection can atrophy without use, making the return to intimacy increasingly difficult over time. But the study also found something hopeful. Even after years of solitude, participants who engaged in sustained intimacy showed neuroplastic changes. New connections formed, atrophied regions regained volume, and the fear-intimacy association weakened. The brain remained capable of change even after prolonged isolation. It just required consistent, repeated exposure to safe connection over extended periods. For those watching who find solitude safer than love, I want you to understand something crucial. Your preference for aloneness isn't a personality trait. It's not who you are. It's what your brain learned to do to keep you safe when connection felt dangerous. And that learning made perfect sense in the context where it developed. Your brain did exactly what it needed to do to protect you. But the question you need to ask yourself now is, are you still in that dangerous environment, or are you carrying the fortress you built in the past into a present that might be different? Your brain's prediction that intimacy equals pain might have been accurate once, but predictions need updating when circumstances change. The problem is that avoiding intimacy means you never test whether the prediction still holds. The research is clear about one thing. Humans are not designed for prolonged solitude. We're social mammals with nervous systems that require connection for regulation, brains that need intimacy for healthy functioning, and bodies that deteriorate without touch and belonging. You can survive in isolation, but you can't fully thrive. Solitude feels safer than love not because it is safer, but because your brain has been conditioned to perceive danger where connection exists. The path forward isn't simple. It's not about just putting yourself out there or being vulnerable. It requires understanding that your nervous system will scream danger during intimacy because that's what it's been trained to do. It requires learning to tolerate that discomfort without immediately retreating. It requires finding safe people who can remain steady while your brain tests whether they'll hurt you the way others did. And it requires patience with yourself as your neural circuitry slowly, gradually learns a new pattern. The science shows that change is possible, but it's not easy or quick. Your brain built these protective walls over years or decades. Dismantling them takes time, repeated experiences of safety, and often professional support. But the alternative is spending your life behind walls that were built to protect you but now imprison you, choosing the certain pain of loneliness over the uncertain possibility of love, and dying having never known what it feels like to be truly seen and still accepted. Solitude feels safer than love because your brain has learned to prioritize predictability over connection, control over vulnerability, isolation over the risk of rejection. But safe and good aren't the same thing. Sometimes the safest choice is the one that slowly kills you, and sometimes the scariest choice is the only one that leads to being fully alive.